Hello, friends. Good morning and good evening, everyone. Your ALP here. So today I am here with one more guest, Tuhinanshu Mishra. He is an electrical engineer. He's currently pursuing his PhD program, and it's going well. And he shared many of his experiences, the projects mainly related to the fuel cell and some other renewable energy concepts. So these things are very useful for any graduate students. They also can do these projects, and it is useful for the MTech projects also. Mainly, it is not only like a project, an academic project, simply doing and going away. You can do like any commercial models also by spending some time and some investment on it. So these things are going to practically help some way. So do watch this video till the end. It's inspiring and a good journey. So he discussed in a detailed manner, shown a couple of pictures of his project also. Yeah, I hope it will be useful. And if you are watching this video for the first time, then do subscribe to this channel so that whenever I'm uploading videos, you will get notifications. You can simply click and watch it. Yeah, keep watching.
Am I audible?
Yeah, hello, Tuhinanshu. How are you?
Hello.
Yeah, you are
Am I
audible.
audible, right?
Yes, you are audible.
Okay. I think
Yeah.
it's not needed.
Okay. Good.
Good morning.
Good morning. Yeah. How are you? I'm good.
I'm fine.
Thank you. So welcome to our channel, ALP Talks.
Thank you very much.
Yeah. Okay. Currently you are at home, right?
Yeah. Right now I'm at home.
Okay. Yeah. Very nice. Thanks for joining here, for sharing your knowledge and expertise, whatever area you are.
Thank you very much for inviting me.
Yeah. So just to say a few things about myself, I started this channel for sharing the electrical knowledge, whatever I have, and simultaneously I am interviewing many professionals and industry experts. Yeah, it's going well, and yeah, very nice. Warm welcome again. So yeah, it's your turn here. Just proceed. Let's talk few things about yourself, your educational background and professional background, who you are, and then we will move to our topic of discussion. Yeah, it's your turn again. Warm welcome again.
Okay. So for about my educational background, first I'll tell that I pursued my BTech from UPTU, that is to say Abdul Kalam Technical University, right, AKTU.
Okay.
And my BTech was from BBD and ITM Lucknow in electrical engineering.
Okay.
I joined in 2011 and I finished in 2015. And then from 2015 to 2016, I started preparing for some competitive exams and all. And after that, in 2016, I joined as an assistant professor in a university. It is in Prayagraj, Allahabad, right?
Okay.
So I joined there. I started teaching certain subjects like signals and systems and power electronics. And for 2 months I taught, I think, and then I joined my MTech in the same university. I'm not in the university that I did BTech from, UPTU. I joined my MTech also there in a different college.
Yeah.
In Prayagraj only, in United College of Engineering and Research.
Okay.
So I started my MTech in 2016 and I completed my MTech in 2018.
Okay.
So in my MTech, I worked on fuel cells. Okay. I published microbial fuel cell basically.
Okay.
So I published 2 international conference research papers in IEEE conferences. And then in 2018, after completing my MTech, I again joined in the same university where I was a teacher earlier before joining my MTech. Right?
Yeah.
So they just increased my salary and then I joined again. Yeah. So
okay.
So I joined there and then I started teaching there again. I continued teaching, and in December 2018, there is a college in Ranchi, BIT Mesra, Builder Institute of Technology Mesra. Yeah, so I got selected for doctorate there, PhD.
Okay.
So yeah, I joined for PhD program there, and then from January 2019 onwards, I was in BIT Mesra only. I started my coursework. For 1 month, you have to do the one semester. You have to do the coursework, right?
Okay.
So I completed my coursework, and then after completing my coursework, I was like beginning to start the research work. But then, I had a complex in my mind that I had not qualified GATE exam, right?
Oh.
So, yeah. So I thought that better qualify GATE one. So I left PhD from DIT Mesra.
Okay.
And I left PhD from there, and then I started preparing from September 2019. I started preparing for GATE.
Okay.
And in January 2020, till in February 2020, the GATE exam I qualified, and after qualifying that GATE exam, I had started applying for PhD elsewhere. Because my hometown is in Allahabad only, in Prayagraj, Uttar Pradesh. Yeah. So I wanted somewhere nearby.
Okay.
Because I'm kind of homesick.
That's true. That depends. Yeah, that depends. Yeah.
Yeah. So
Okay.
so I applied some nearby. So
Okay.
I got in admission in Allahabad only, in NIT Allahabad.
Okay.
So I thought that nothing better than this in my hometown only.
That's true.
So, yeah. So then I started PhD here in 2020, right?
Okay.
So since 2020, I'm doing PhD in NIT Allahabad. So that's my educational background.
Yeah, very nice. Yeah, your talking skills are so good. I think it may be due to teacher, or it may be by both. I don't know. Yeah, of course, it's good.
No, it totally depends on whom I'm talking to, right? You are a very good person. Talking to you is
okay.
It is mirrored.
It's not like that. Okay. Very good. So do you have passion towards teaching, or what?
Yeah, basically, I want to join teaching only. I want to work as an assistant professor. Let's see in which college I get, depending on my performance in my PhD, right? If it will be a good quality research work, then I'll get a good college. Depends on that.
Okay. Yeah. Generally, for this teaching field only, we need MTech, mostly MTech and PhDs. In remaining areas, yes, the chances, which opportunities are there, but not that much. Mainly for research field, mainly in India. Okay. Yeah. Very nice. It's a wonderful and inspiring journey you had.
Thank you.
So you the dream of qualifying, that also it's clear. Yeah, because being in colleges, you are interacting with many people, many students. So
that's what.
Before teaching them, you also, if you will get good confidence also how difficult or how tough the things are, how actual the scenario is. So you will get better under. So you are almost closer to the student level now, because you started homework on it. Yeah. Okay. Very good. So how the student interaction with you? So because these signal systems, power electronics are mostly related to the applications in the actual industry. So machines, that is okay. That is since many days it is there. So how students are interacting with you? Regarding
students interaction with me. Fine.
Yeah.
See, the university that I joined, right? It is a rural university in Allahabad.
Okay.
So it's not a very big university. Fine.
Okay.
It's not a city university and a very posh area. Fine. So the students belong to rural background.
Okay.
So teaching them was a challenge. Like first you had to adopt in the methods, like you had to adopt Hindi also. Like you have to mix Hindi. If I started teaching in English, they would not understand. They would not get it, right?
Okay.
They wanted easier language. They wanted me to explain everything to the basic concepts, right? For example, if I'm telling them about systems, right? Signal systems, I'm starting about systems, right? So I'll have to take a basic example from the building block, right? That what is system, what is signal, then what is future? How do you deal in systems in the future, right? In day-to-day examples I have to take. starting from the and those examples that rural people understand, right? So but you will be surprised that the students of the rural area are so intelligent, like they grasp it so easily.
That's true.
So if you try to explain them, they will get it very easily.
But
it is the bad luck of people that they don't have proper facilities.
That's true.
Otherwise they are very intelligent. And I would say that some of my students almost 5 to 6 students after I left that college in 2018 and it is 2021, until now they contact me every day, every morning, and they send good morning and good evening. So yeah, they're very cultured also. I'm not seen in city areas and all that. Okay, for college students contacting their teachers daily, it is a good thing.
Some people will, some students are like that. They're favored to few people and they will be in contact with them. So that's true. So I also still in contact with a couple of my professors regularly, maybe weekly manner. That's general discussion. It may not be subject, but general also. It's good. It's good to have interaction with both. The faculty also. Okay. Very good. The rural area students, they can grasp easily. Only thing is we should show the path to them. So what are the things? At least initially we should help them. Maybe after a couple of years, they can grasp things better way than us, we can say.
True.
Okay. Very nice. So let's move to the topic, your MTech topic, the fuel cell related. So the design of fuel cell using mixture of domestic
paused,
waste.
I think.
Okay.
Video is paused.
Video is paused?
It's all right now. It's all right.
Okay. Can you speak? Can you discuss that about that research paper, fuel cell related? What is that project?
Okay.
So let's give a detailed discussion on it, because mostly, the source you taken from that domestic waste, that is a different thing. But mostly that fuel cell concept is important in these days also. Mainly electric vehicles. So many people are moving towards it. So we will discuss a bit details on it.
Sure. See, there are different types of fuel cells, right?
Okay.
What I worked on was microbial fuel cell. Okay. Now I'll tell you in detail about microbial fuel cell. What is it?
Okay.
So basically, what you do is that what my microbial fuel cell did was that I took cow dung, right?
Okay.
Cow dung and domestic kitchen waste, vegetarian kitchen waste. I took these two things as my fuels, right?
Okay.
And then I mixed them in, suppose, in 1:2 ratio. I experimented with many ratios, 1:2, 1:3, like one cow dung, two kitchen waste. Experiment with almost 20 ratios, right?
Okay.
Then I mixed them in a 3-liter chamber, right?
Okay.
And then that cow dung, what the specialty about cow dung is that it contains a bacteria. It's called an exoelectrogenic bacteria, right? So it is in the human chamber of the cow. Okay. So what happens is that that bacteria has the ability to degrade cellulose and then generate electrons, right? So what happens? So what happens is that kitchen waste that you provide, it has a lot of carbohydrate and cellulose, right? So it takes in that, and in the cow dung also there is, even if you don't use kitchen waste, the cow dung also has some amount of cellulose, right? So that also it will degrade it and it will generate electrons. And if you provide surplus cellulose, like from kitchen waste, right, you are providing more cellulose and it will degrade that also.
Okay.
So when it will degrade it, it will generate electrons from it, right? And that electrons, what you do is that you provide a path, right? Through the wire, external circuit. And through that external circuit, you provide the path to the electrons. So electrons flows in opposite direction and current flows in the right, that. So that thing happens, and we obtain the current. We in the external circuit, we let the current flow, we let the electrons flow, and there we connect the loads, right? So it powers up the loads in that way.
Okay.
So
did you have any more? Any capacity like that? Did you assign any specification for that? Maybe 1 kilowatt, 2 kilowatt?
Right. So the voltage and current rating are very low, I experiment with, I told you earlier that I experimented with about 20 ratios, right? So the best output was obtained in 1:2 ratio.
Okay.
So in 1:2 ratio, I think I remember I obtained about 600 millivolts, right?
Okay.
600 millivolts of voltage, 600 millivolts of voltage, and approximately 375 milliamperes.
Okay. Okay.
Of current. Yeah, it was very low.
Very low.
But the problem is that suppose if you take potato, right, you can generate electricity from that also, right?
Yeah.
So, but it will not last that long. But that fuel cell, I like I experimented with it for 20 days, right? So the output was coming for 20 days also.
Okay. Okay.
It was obtaining peaks, and then it was going down, and then in few days it obtained stability. And so on. So I observed it for 20 days. I don't know if I might have kept it later on. Maybe it would have given output later on also, but I experimented. I took my study for 20 days period.
Okay.
So that's what.
Okay. I mean, in this entire process, so what is the incubation time like that? For example, you taken the cow dung and domestic waste. So you mixed it.
Right.
Generally, from when it will start? Say, for example, now you just mixed it and kept in the chamber. So from which time the production will start, and how many days it will come, and what is the frequency of putting a new cow dung and new domestic waste?
No. Actually, the thing is now that in one night, I kept the cow dung, domestic waste enclosed in a bottle, and cow dung in another bottle for one night, right?
Okay.
Anaerobic. I made it anaerobic without air, right? Yeah. So I enclosed it in bottle and I kept it for one night, and then the next day in afternoon I opened it and then I mixed it in the mixture, right?
Okay.
In one chamber, okay. And then I let it be like that for one more day.
Okay.
And from the next day I started obtaining output.
Okay.
Now for the 20 days I did not change it, right? I did not remove the because the chamber that you are keeping your kitchen waste and cow dung, it has to be anaerobic. If you remove it, air will go inside, and the bacteria will be, so it has to be anaerobic. So if after 20 days, or like I did not experiment by changing the cow dung, right? So maybe it is a possible prospect that if you if the output of the fuel cell might have gone down, if after that you might have removed the existing fuel and then you would have taken a new fuel, then it would have been replenished, right?
Okay. Yeah. So to that chamber, how you connected the leads and all? I mean, did you use any battery or it's only probes, or how you connected? Did you have any setup or pictures?
Okay. Actually, the battery, if I will connect an external battery, then what is the use of making a cell? Right? That cow dung assembly was in fact in itself like a battery, right? Okay. So I'll show you a picture.
Did you use any electrode plates like that, or it's like
the graphite electrodes. Graphite electrodes.
Graphite electrodes. Okay. Is it in generally what will be the shape of that? It's like a plate or
no, it's cylindrical.
Cylindrical. Okay. So they are concentric, positive and negative electrodes both concentric each other. I mean, two cylinders like that.
Yeah, two cylinders. It's not showing up. Wait, I'm sharing my screen. Okay.
Oh yeah. I think I should allow you. Yeah.
Okay.
I allowed you. You can proceed now.
Okay. I'm sharing my screen. Dissertation.
Yeah, proceed.
Is it visible now?
Yes. It's visible.
So this I made the hardware I made in my MTech, right?
Okay.
So one, So one chamber is filled of the pink chamber. You can see is full of cow dung and kitchen waste, right?
Okay.
And the blue chamber is full of water, right? Distilled water.
Okay.
And that distilled water is aerobic.
Okay.
And that cow dung chamber is anaerobic. And then there is a salt bridge. And there is multimeter. You can see it is obtaining about 1, 2, 3.
So why you use a salt bridge there? Salt bridge means that electrode place you used it.
Yeah.
At electrode place you used the salt bridge or what?
No. See, the electrode is different. Salt bridge is used for the transfer of ions, right?
Okay.
Yeah, from one chamber to another. The transfer is taking place, right? See, when you are, should I unshare my screen, right?
Yeah, let it be for a few more minutes. So
okay. I'll let it be like that. So the thing is that when two chemical reactions take place here, right? So hydrogen ions pass through this salt bridge from one chamber to another, right?
Okay.
And electrons pass through the external circuit through the wire.
Yeah.
So yeah, it has to neutralize, right? So in order to do that, electrons are generated and electrons pass from the external circuit to the wire, and hydrogen ions pass through the salt bridge. So there has to be medium for the hydrogen ions to pass now.
Okay. So those two chambers are you connected through small pipe connection like that?
Yeah. There is a pipe. I
Okay.
drilled holes in the chambers and I connected it with M steel, right?
Okay, so one is the distilled water, another one is powder, right? So they don't mix up easily, or how? Because
no. The connections are made like that now because the salt bridge is not empty, right? Actually there have been 3 years and I don't know exactly. I don't remember exactly what dimension I took. So it was as I remember, I took a cotton, a thread, right? A thick cotton thread, and I mixed it with certain chemicals, and then it was stiff looking. It was like a gel, stiff gel, and water and this cow dung could not mix easily. And now you talk about mixing, then I'm remembering that I think about after 20 or 22 days it got mixed because it had been 20 days and it was restraining from mixing, right? And it was working very well. And it could not hold very longer. So it was, after 20 days or maybe after long, when I stopped my study, after a long time, it got mixed. But it had mixed at one time. So maybe you can, but the thing is not that it is very cheap. You can afford by, and it is educatable to every person, right? If you're making it in a rural area, right? You can educate the person to make it. It's not that difficult. Once you educate them about the technology, they will know how to make it.
That's true.
The only drawback about this is that the output is very low, right? Because we can't do anything with 600 millivolts and 375 milliamperes. We cannot even charge a phone, right? So but there is a prospect, there is a possibility that we can work on it and we can improve the output with small volume. Right. So I've not worked on it and I left my work at this stage only.
Okay.
Yeah.
I think you discussed, you mentioned about boost converter. So have you used boost converter here? I mean, for boosting these parameters?
Sure. I'll tell you. For what I did that this output was, I told you 600 millivolts, right? And I also mentioned you that it is very low, right? So suppose you want to charge a mobile phone. Again, I'll take an example of mobile phone because I mentioned mobile phone earlier. So suppose you want to charge a mobile phone and you are not getting a sufficient voltage. Now current, if you are getting low, it is fine. You will take more time to charge the
That's true.
Yeah. But you need the defined voltage, right? So suppose you use a boost converter, you boost the voltage from 600 millivolts to say 5 volts. But when you will boost the voltage, the current rating will go down, right?
That's true.
Because the power has to remain constant, right? So then you can at least you can power up a mobile phone. You can charge it slowly, very slowly. It will charge, but it will be able to charge, right?
Okay. That's true. Okay. So did you have any hardware model for that? I mean, you have built any converter physically or what?
Okay. See, the hardware I made for the battery only. Okay. This boost converter thing I did on the simulation.
Okay.
Yeah.
Okay. That is like a DC-DC boost converter, right? Yeah.
Yeah. DC to DC converter.
Okay.
It's like it will take DC input and it will step up the DC input, right?
Yeah. Okay. Okay. Yeah, you can unshare the screen. No issue.
Okay. Thank you very much.
Yeah. Okay. So these models have you observed anywhere in India or abroad, like this fuel cell with this cow dung concept and all?
Cow dung.
Is it only in India, or how? I mean, how you got this thought to do? I mean, anybody suggested it, or you itself?
Okay. See, whenever we start a topic, right? I'll tell my case, right?
Yeah.
So my supervisor in MTech, he told that you have to work on fuel cells, right?
Okay.
So I searched a number of fuel cells. So first of all, I came up with I started working on a fuel cell. I think it was boron fuel cell, like boron oxide fuel cell, I think. So in my first semester, so it was I worked on that for one semester, third semester.
Okay.
I worked on it one semester, but the study was failed, right? I could not achieve, because I realized after at the end, right, at when my dissertation in the third semester, when my dissertation was to be held, at that moment I realized that I had committed a mistake in my understanding one basic chemical equation, right?
Oh, okay.
So yeah, so that study was a failure, right?
Okay.
So after that I started, and then I thought that the thing that I wanted to do, that was a cause of that equation only, and then when it was failed, I thought that then there was no use to pursue it further. So I took up another fuel cell, and this microbial fuel cell was, right, I searched on it and then internet and all, then it was in trend, right?
Okay.
So it was under study in 2018. So I was interested in this also because it used renewable energy, right? It would take waste and absolutely waste, right? It has no use. So it will take the absolute waste and it will convert it into electricity, and that is a good thing. So I was interested in it.
Okay.
And I started my work on it. So that is how I started my work on it, right?
Okay. Yeah, I remember one incident in my village itself. So we have gobar gas concept. So same thing, cow dung and domestic waste they will use, and they are going to get the gas, and instead of regular LPG cylinders, whatever we are purchasing, they are going to use the gas generated from that plant itself. So daily, every morning, so they used to fill that chamber by mixing with a little bit water. So how because there it is generating gas, right? So here methane, ethane, and combinations will be there. Here, how, I mean, in this concept also we can still generate the gas if you go for a bulk model.
No, see, if you are mixing two things, right, two elements, you are mixing these cow dung and domestic waste, right? They will generate gas, right? If you are mixing it in a pit, they will automatically generate gas, because you can, if you are making a model on another principle, you cannot stop another principle from happening, right? It will automatically generate gas. So, but here what we are using is that we are utilizing the bacteria in the gobar, right? In the cow dung. We are utilizing that bacteria to generate electricity. So the electricity generation is happening by an entire different principle. We are not utilizing the gas. If you are utilizing, if you want the gas that is being generated, you can supply it to another cylinder, and then you can fill it there, and you can do two parallel processes at the same time, right? You can fill the cylinder, and you can collect the gas also, and you can generate electricity also. So you yourself you told me that there can be two advantages, right?
Because I am getting that doubt, because in this model, whatever you shown, the left side model is gobar gas. It is anaerobic, and there will be a possibility of generation of gases also, right? I mean, have you thought of that observation? I mean, did you have any discussion on that area? Because electricity will be there and domestic gas also will be generated. So
sure. It has a possibility. You suggested a very good thing, that we can usually, because it will be anaerobic, it will be sealed, and gas will be generated, and we can drill a hole and we can collect it somewhere.
I am not sure how. I mean,
but I'm also not very. I'm not in the chemical engineering.
I
area. I'm not specialized in the chemical engineering area.
Okay.
I only did my research which was in my zone, right?
That's true. That's
electrical, right?
That's that depends.
So
Yeah,
maybe they will listen to us and they will say that this is a joke, right? So
yeah,
I don't know.
Okay. Yeah, I'm not saying it may not happen. It can happen because I see in physical.
Sure. I
Because
also think that it can
in my village itself, since I am still today also it's working on. But generating it is generating gas. So they are using for household purpose. So that's what, because the was also similar to cow dung and waste, that they are also using same thing. If for example in this same my village scenario, if we install other setup like a distilled water and those things, there may be a possibility of generation of electricity too. Maybe like it may be a little bit manner, but yes, it may be good idea. So yeah, I will no issue on that. So I will discuss with chemical engineering people also. In the future. I will
and let me know also, because I'm interested in.
I will bring good discussion on these topics also.
Sure.
Very nice. Yeah. Okay. Yeah. So I think you did another project on design and fabrication of
So,
alarm clock, right?
You have done your homework, right?
Yeah.
So while I was in my BTech, right? In my third year, I started. I was interested in some research. Like I didn't take any help from anyone, and I started on my own. Right? I was like, I will do it on my own. So I studied. I was studying piezoelectric elements. Right?
Okay.
So on the basis of piezoelectric, it is long back in 2014 or 13. I started this work. So I started this piezoelectric. I took the piezoelectric element and I designed a topology. It was a very newbie work, So I designed a new topology so that what it would do, that suppose you take I took an alarm clock as an application. You can take any device. So what will it do, that you take a battery and rechargeable battery, right? And I designed a new circuit for that. Okay. And you place that circuit in an alarm clock. Okay. And you place your rechargeable battery in that circuit via that circuit in that alarm clock, right?
Okay.
Now what will it do? That the alarm clock will generate certain sound energy, right? It will have vibrations, right? So what the piezoelectric element does, that it changes the mechanical stress. If you put some pressure on it, right? So the piezoelectric element changes that energy from the mechanical stress, and it converts into electrical energy, right? So recently they utilized this. I read it in the newspaper. They utilized this piezoelectric element in a railway station, right? Some students did it. They made a device and then people used to jump on it and then it generated electricity.
That concept is there. That is like a footstep generation.
Footstep. So for in my research, what did I do? That I basically I made a new network, right? New circuit, and what that circuit would do, that it would use that sound energy to recharge the battery. And when the battery will work, and battery will use it. I used two batteries, right? One battery will make the alarm clock work, right? And another battery will charge. Okay. And when that battery will charge, it will work. So it will charge one time.
But it seems like a coupling, right? I mean, energy. We have a law of conservation of energy. So because energy can be neither be created nor be destroyed. But here, what you are doing, you are using one battery and generating. I mean, clock is working. That sound energy you are using again, and you are going to generate it. So how, for example, in that sound itself, for example, if you consider about big speakers or for example, marriage function halls, many very big speakers, you might be observed it. There itself, we have many setup for generating the sound. We need more energy also. Now what you are doing, you are using that sound, and is it feasible? I mean, did you study any feasibility?
It is feasible, but you know, the piezoelectric element should have very high sensitivity, right? To utilize the sound, and then You have to work on how many piezoelectric elements you have to place, and you will be able to do a lot of research for that, and it is possible. Sure, it is possible.
Okay. I mean, at the time your model is success, or you stopped in the middle, or what is the case there?
No, I did it. I published a paper in a journal, right?
Okay.
In my BTech only, in my third year only.
Okay.
Yeah.
So generally, how much time it took the battery took for recharging from the sound energy?
It was more of
specific?
a, I'll tell you, it was more of a theoretical paper, right? I proposed the concept, I did some calculations in the lab. I didn't actually make the alarm clock, and I didn't actually design the hardware.
Okay.
It was I did certain, because I was in my third year, and I was doing it on my own. It was my first project, right? I was just like, I want to publish a paper, and so I did. It was I did not work on it in very deep, right?
Okay.
So that's what.
So wherever we will have this sound pollution or these areas, then we can have those things actually.
Yeah, sure.
For generating at least for signal lights.
Basically, what you can do is that please.
For signal lights or some area, I mean, for at least indicating lamps, something we for industry also. For example, in power plants, in some areas, a lot of sound will be there. In those areas also.
Not only sound, you can take pressure wherever pressure is applied. For example, I'm suggesting you one thing, like there are subways, right? There are subways. There is a lot of pressure on that subways. I mean, with the people walk through tunnels underground, under the road, right? You might have seen in cities like Delhi. And the traffic goes on above the road, right? So automatically there will be a lot of pressure on the road, right? And there is a lighting system underneath the subway, right? So you can, like, if you work on it, if you increase the sensitivity somehow, you can utilize that circuit, and you can power up the entire subway from renewable energy, right? There's energies, you're not using energy from the grid supply, right? Like you're converting one form to another. So
so being electrical, you touched sound energy and other areas also. Chemical and all. Okay, no issue. It's very good. I mean, we should be like interdisciplinary. Somehow your thought is you should be appreciated, because in third year you did that project. I also will check if any such things are there in the world. I mean, it's somewhere I will interact. I try to interact with them also. This footstep energy, I know some people who did some models also, so I will bring discussion on those topics also. So very nice. So many topics we discussed today. It's
thank you very much.
It would be useful to many people, many students, particularly the who are, because it will.
You have taken a very nice initiative. It will be helpful to many people,
because it will ignite their minds. For example, in projects, what the main thing is, we are doing project means we are spending some time on those things. So who knows that their job, that their career may be pushed towards that project itself, because that depends. That may be sometimes that may lead to new area of research also. So it may change many lives. It may help many people. So that is my main intention. So because you did these things, so if any person watches this video, they will get some better understanding about these things. Because at that time you may not know anything while doing. It's like a trial and error. Nobody to guide you.
Sure. And they can contact me also. My email ID is
that is my main intention here. I'm providing the
they can contact me. I'll be more than very happy to help them and support them.
I am providing contact details also. People can watch this, and if they are interested on these things, they can directly contact you, and they are not starting from scratch now. They are starting from experience of you. At least some parameters, 600 millivolts or whatever you told. So at least they are starting from that parameters. So they can think of if they want to start direct 2 volts production, how big the chamber should be, what should be the contents inside. They need to add any chemicals to make the process speeder. So like that they can think of. So that is the main thing, main discussion here. Yeah, very nice, Tuhinanshu. So it's very good discussion.
Thank you very much. Thank you. Thank you very much.
So this is not the end, I can say. This is just a start for our combination. We are going to do many more things.
Yeah, I wanted to talk about the project, right?
Yeah.
So if you, next time or anytime, if you allow,
yeah,
we'll discuss that also.
Yeah, you take some time on that, work on it, and we will discuss the topic also in a detailed manner. Okay, thank you. Thanks a lot, dear.
Thank you.
Bye.
Thank you very much. Bye.
Thanks, dear. Thank you. Thanks for watching. This is about this video. So I hope this content and information is useful to you. If you have any doubts or any questions or anything, then you can contact me. The details of the guest also available in the description. You can check with him, and he is ready to help you. And if you're watching this video for the first time, then do subscribe to this channel so that whenever I'm uploading videos, you will get notifications. You can simply click and watch it. Yeah, we will meet in next video, guys. Bye. By the time, keep searching my videos so that you will get some good exposure on electrical topics. Bye.